All right. Hello, everyone. Welcome back to the Anarchist Project. Tonight, we're going to be starting a brand new project, which is awesome because we've been working on the same one for like 2 months now. And it's exciting to I kind of hate throwing everything away and starting over, but that's not really what we're doing. We're moving on. We've completed that. We're moving on. But I'm excited to just start fresh and take what I've learned from this past project and learning, how to stream and everything and interact with you all and move on to the next thing. So tonight we're starting a new project for a friend of mine and one of our viewers who's reached out and requested a project. As you know, if you check out the About section on this page, on this channel, you can see a spot to request projects. And so that happened. We got our project request. It looked like a good one. And so we're going to try it out. So without further ado, we'll jump into this. Actually, I do want to hold up and say one other thing. This is going to be a kind of a completely different format than before. Before, building the Lego set and then lighting it up, I already kind of had an idea in my head exactly how I wanted to do it. And obviously the Legos were done through instructions. And so we kind of just followed the instructions, and then I more or less dictated the path forward on lighting it up. Well, this time around, we have requirements supplied by another person. We are not making something for ourselves. We're making something for for a customer, if you would think of it that way. And so we have to adhere to those requirements. And not only that, we have to take a more formalized development because nothing is really set in stone. However we design and build this thing is the way that we want to do it, not the way some instruction manual tells us to do it. So we're going to have to do a little more planning and then be a little more fluid later on. Things could change over time. And so I've taken the time to kind of get a really, really high level kind of development process figured out. But it's basically just plan it, test, or plan it, prove it works, build it, test, whatnot. And there's not a lot to it. So that being said, as we go through this, the process may change. We may have to, do a few things that we weren't expecting or change up what we're doing just because we encountered some unexpected difficulties. So that's what we're going to be doing, and I'm going to start off with the planning tonight, and we're going to just plan out some high-level, we're going to create some high-level diagrams. I'll just kind of plan out the assembly of this thing, how exactly the circuit's going to look, and then if we get that done, we'll jump into starting to make the schematic, because I think I want to make a custom circuit board for this one, which I think would be really fun and allow you all to see, not a lot of people have seen exactly how that's done. It's not actually that hard to do or that out of reach. It's not that expensive or anything. Surprisingly, it seems like something like that would be, but it's not. And so I'm going to take this opportunity to show you all the viewers exactly how a circuit board can be designed and purchased, from some company and then used in one of your own projects. So I think that'll be cool. So then, without further ado, let's get started here. I'm going to jump into this scene, and I think we need to change our current goal. That's from last time. When we finished up, I was like, all right, we need to celebrate. Well, now's not the time for celebrating. Now's the time for getting work done. So all right, there it is. Let's change this to... I guess first things first, we need to plan out the schematic. Or create block diagram of schematic. That might be a little too specific, but we'll leave it for now. Cool. So the first thing I pulled up here is actually these project requirements. This came to me in an email through the request system, but I went ahead and formalized it into a document. Those of you that follow me on Twitter may have seen that I tweeted out with a link to the GitHub. I posted this document in the project on the GitHub so that everyone else could see it as well. And it's pretty straightforward. There were a few things that I had to go back and clarify. If you request a project, one of the things it will ask you for is an email, and that's so I can get back in touch with you if I think there's something that's not necessarily clear or I'm unsure about in the project, so I can get some sort of clarification and then modify the requirements accordingly. So I'm going to just scan through these real quick and highlight some of the important or difficult things. And then we will go through and start making our block diagrams and figuring out exactly how we're going to do this. And then we will start designing a circuit, which should be fun. All right. So first things first, project summary. Here, I would like to make a MIDI controller that enables me to control parameters within my digital audio workstation. Pretty straightforward. MIDI controllers can be very complex or very simple. If you go look on Amazon, you can buy them. You can really spend about as much money as you want to if you want to buy something very cheap, or if you want to buy a very, very nice one, at the top end. You can spend thousands, tens of thousands of dollars really on this stuff, depending on, what level of you're doing this at. If you're just tinkering to see if you enjoy, making music, or if you're doing this professionally. I mean, the spectrum goes the whole way. So in our case, we're going to try and make a cheap one at home, because even the cheap ones can be kind of expensive sometimes. And we just want a small little one for basic use as specified here. So these last two major requirements are really the most important, because this dictates exactly what kind of use the person who requested this wants. And that is that they want 3 volume sliders and 4 buttons. So that's the primary end all be all. Like, that's what we want on the MIDI controller. And those must be usable within, any standard recording software. And then all the other requirements kind of center around that. So must reduce costs, must work on Mac OS or Windows. The person who requested this uses Logic Pro X to write music. Must be able to customize what the sliders control. Must not slide around on the desk during use. That makes sense. And then slide should be 60 millimeters. I spec'd this out very specifically because this would affect the overall size and everything. And then finally, we have a few project preferences. The customer prefers that USB-C is used for the connection. They prefer some sort of graphic overlay on top, so some sort of label or print on top of the device that labels each of the buttons and each of the sliders so that you don't get confused. They would prefer the sliders to light up. They would prefer the buttons to light up. That'd be kind of cool. And they would prefer a USB-C port on the device. This is different than the first preference. And the first preference is that a USB-C can be used to connect it to the computer. The USB-C port on the device is a preference for letting basically, instead of having a cable come out of the device that's permanently attached, we can actually detach the cable from the device itself, and the device will have its own USB-C port that we can plug into. That way, different size cables can be used, and it's very modular. So all those requirements, I hope, are pretty straightforward. We can modify them accordingly as we need to. But let's get into our diagram. And I think first things first, we need to figure out what our schematic is going to look like. So let me pull this up. This is just a little, some diagram software that I downloaded so that we could easily make this stuff and that I could show it to you all. I didn't really want to use Google Docs for everything, so I downloaded a lot of third-party software to do all this stuff. All right, our schematic. Really what we're speccing here is not necessarily the schematic, but the actual circuit board itself. So yeah, let's just start with a rectangle. And we'll say that it is our circuit board. Also, if you have any questions, or if you just want to ask me about something random or talk about something random, please let me know. I enjoy the distraction. So all right. And I know this is really small on the screen. I promise to make it bigger. And we'll make it bold as well. All right. Circuit board, and then we'll make this color. Actually, let's make it green, since circuit boards are green. That seems to be a good idea. Okay. So we need 4 buttons and 3 sliders. So the sliders are going to be what we call, they're sometimes called linear potentiometers. I've noticed that term seems to encompass not only slide switches, but also another type of potentiometer. So we're going to call them slide potentiometers because that's more specific. All right. So let's say slide potentiometer. And we need to make this a little bigger so you all can see it. Definitely. Maybe too big. Okay. And then we'll just leave them down low here, and then we'll need to make 3 of these. There we go. So 3 slide potentiometers, and then we need 4 buttons. So let's do that. And we will put that up here. Oops. All right, and this diagram is not going to be totally symmetrical, but it will. Have you ever used the Goblin controller? What is that? Is that a MIDI controller that I? Ah, very nice. Very nice. Jumped right into that one. All right, so we need that, and then we need our main control board. So what we're going to use for this one is a Teensy 4. All right, so that'll be our main control board. So that's pretty much all the major features right there. And then I suspect that whatever enclosure we use is going to need somewhere to mount to. I don't know how many it'll have, but we'll just go ahead and place these around. All right. Okay, and then what else do we need? So we have mounting points, buttons, Teensy. The Teensy is going to contain the Teensy will have the point where we plug in for power and such. So there really isn't a whole lot to this. This is not a very complicated circuit. I don't think there's anything. I'm trying to think if there's anything else major that we need on the circuit board itself. Let's see. Nope. All right. And then we'll make this orthogonal. There we go. Okay. Just want to have a good clean diagram. All right. Connect that there. That over. Nope. Okay. And one more button. All right, and then we have to connect the slide potentiometers as well. All right. And one more. Okay. May find later on that we need to get more specific about what exactly or what exactly is on here. Like we might have to add more details, but for the moment, I think this will suffice. And just kind of color code everything so that it's pretty straightforward. No. I'll just say it's another. That. Okay. And then we'll save that. Awesome. All right, so anything else? I think for the most part, this is fine because this just shows exactly what the circuit board is going to look like. The assembly diagram is going to be quite a bit more complicated. Yep, I think that's good for now. Okay. So now that we got that decided, let's work on the assembly. Oh, excuse me for just a second. All right. So for this part, we know that okay. How we design this is going to have to take some, we're going to have to put some thought into it because otherwise we'll probably have to redo it a little bit. But I'm going to do this. Actually, I'm going to make this a little wider. And then we're going to drop a second one of these. So assembly block diagrams are kind of tricky in the sense that like it can be tough to do them in a way that inherently makes sense and is organized. But it is a really good way of showing others what exactly you're talking about as far as the overall assembly of something. So to start, we're going to label these. So I've got two blocks here, and our enclosure is going to have a top piece and a lower piece. It's basically a big plastic shell. We're going to buy some sort of pre-made enclosure. And what it'll come with is a top piece and a bottom piece that we have to then put together. I wish I could change the default font size to be bigger. I probably can. I just need to go find out how to do that. All right. We need the bottom enclosure. And this will dictate everything that is going to be mounted in the bottom, and then everything up here is going to be mounted in the top. We'll dictate features as well. So let's get started and say, what do we need? Well, we know that at the bottom here we're going to have our PCBA. Whoops. All right. And I'll make this a little bigger because I'm going to have to connect a few other things to it. All right, within this bottom shell, there's going to be several mounting points. Usually these enclosures that you buy come with mounting points of some sort. And you have to design your circuit board or whatever you're putting inside it to fit that. So we'll just say points times 4. Or I actually prefer it to be on the other side. 4 times mounting points. Right. So by notating things as like basically up against each other, like connected to each other, we say that in the actual assembly they will be connected, and that will be the case here. Then I'm actually going to slide this over a little bit and drop one here next to it. And we're going to use some screws to hold everything together. And then we can actually add we can add some of our PCBA features within the PCBA here. And we could say points. Okay. Now, what else do we say in our document? So we got our PCBA, we got our things there. Yeah, this is actually going to have to be quite a bit bigger so we can fit everything here. And actually, our top enclosure is probably not going to have that much in it, so I could probably shrink it down a little bit. Okay. So in here we have 3 times our slide potentiometer. And we need 4 times our buttons. And then actually, I'm going to adjust this diagram because it actually goes up into the top enclosure as well. So these buttons, while mounted to the circuit board, have to go up into the top shell because obviously you got to touch it. The button's going to be on the top of the device, and then it has to go through the top shell so that the user can use it as well. All right, so then we need to specify probably that. So 3 times slots, or slot cutouts maybe. And then 4 times circular cutouts. Actually, we'll move that up because that's not related to the bottom shell at all. Okay. So that's how it's going to pass through our top enclosure, is obviously the slot cutouts. Okay. Now, whoops. I think we specify, so in our preferences, let me send this to the back. We specified that we wanted some sort of label or something on this. So we'll specify that here. Label. And then we might have to specify the exact same thing that we did before about the cutouts. Okay. So we have our potentiometers, our slide potentiometer switches coming up, and our circular cutouts for the buttons coming up. We assume they're going to be circular. We could end up using square buttons for all I know. So that might have to change later. And then last we need, on our PCBA, we know that we have a TNC which has a USB, micro USB mount. So we're going to need to specify that. There we go. And let me make that text a little bit bigger. So our micro USB connector, and then we need to, here, I'm gonna move this over, well actually, yeah, I'll move this over here. This as well. I know it's a little weird having the labels on the other side, but we need to specify how exactly we're gonna do our USB-C port. And I think for now, we just say that it's gonna be in the bottom shell. But we're going to need a cable to connect the two. Actually, I think we can drop that down here. And then let's move that over and then move this back. Okay. USB-C. Let's just say port. We'll know that it goes to both sides. And then we'll actually kind of extend that out a little bit. Show that it goes out of the device. And then here we have our USB micro to USB-C cable. And that's going to connect to our connector right there. Okay. And then we will make that a little bit bigger. Whoops. All right, there we go. Slide that back over. Awesome. Okay. So this specifies most things. What else are we missing? Oh, the screws as well. With this enclosure, we have to hold the top enclosure to the bottom enclosure somehow. So we need power. Power's passed through the USB cable. So I think that's already taken care of. Unless there's another way I should draw it on here. But we do need... Let's see. Terrence, what we're doing is the USB cable is coming into the micro USB connector. The USB connector is on the Teensy itself. And then there is a 3.3 volt output pin on the Teensy, which will run to the potentiometer and the buttons. So power will go into the Teensy. Its own voltage regulator will take care of stepping it down to 3.3, and then we'll run that out to the buttons and everything. So we don't have to have any kind of step up or step down. All right. Mounting points. And then what do they call those? They're like bosses, right? Is the term for a raised like section that connects to a screw or something like that. Oh, and then I'm going to have to move all this over. Let me just slide that over a bit. Slide that over there. Slide that over there. Offsets. That's another good word for it. I think I saw it call it a boss one time on in like AutoCAD of some sort. Like that was the name for the feature. But I think offset is a good word for it. And then we'll just say, change this to 4 times mounting point. And then we need to have screws going through all of that. All right. 4 times screws. Okay. I think that's our entire assembly diagram based off of our requirements. Also, Terrence, you mentioned something about last time about using potentiometers and having to clean them up. And I found a great little algorithm to clean them up in software. Clean up the ADC measurements in software, so thank you for that advice. I think that's everything. Let's do one last double check. Reduce costs. Slide. Yes, absolutely. Love saving hardware. Fix it in software. That's the motto every company should live by. Although that can be annoying to the developers. All right, 3 sliders, 4 buttons, preferences, USB-C, graphic overlay, light up sliders, light up buttons. We'll just get sliders and buttons with lights inside them. Graphic overlay, that was the label, USB-C port, USB-C for connection. I think that all works. I think we got everything. Okay. Let's color this, I guess, so that there's at least a little bit, you can at least, I don't know, differentiate a little bit. I don't like that. right. And then we'll leave that one white. All right. That kind of differentiates things a little bit. So, perfect. All right. Once again, if anyone has any advice or questions or anything or feedback, that'd be awesome here because I want to make sure that I'm not the only one designing this. Make that match. All right. So now the next part, and I've kind of been dreading this a little bit, but I have to make the circuit, and that means learning a brand new circuit design and PCBA design software, which I tinkered with a little bit. I decided to at least make a new project in it and everything, but yeah. I don't really know what I'm doing, so we'll see what happens. All right, let me get that started. Doing this off on the other screen real quick, and then I'll bring it over here and we will start working this out. Okay, there we go. So this is going to be a lot because we need to decide a lot of different things. Here's all this. Okay, here's the whole schematic. I'll leave that bottom piece in there as well. And then I'll have to go through and figure out how to edit these variables later. So now that we have our basic block diagram, and I'm going to go ahead and pull up, here's our PCBA diagram. You can see it's very simple. TNT4, 4 buttons, 3 slide potentiometers. Because of the way that we can do this with the TNC's own voltage regulator and whatnot, there's really no other hardware. We could debounce the buttons physically, with a resistor and cap, or we could debounce it in software as well. So both options are on the table, and I just kind of lean towards software because it's a lot easier to adjust after the fact. And in this case, we're trying to save cost as much as possible, so that does save parts. And then you can see it has mounting points as well. So yeah, we're basically just going to do this. It should be a very straightforward schematic. I say that now, and then we can go from there. All right. So let's get a component, and then we need to choose one. And I don't know entirely how all the libraries work here or what stuff is already. Are your use cases defined? Kind of. This is still very open-ended. Actually, let me pull it up real quick. The only use case we really have is a very high-level one, which is the person who provided this must work within my digital audio workstation. And he was nice enough to supply the operating system and the specific program that he's using, Logic Pro X. So, and that is really our only use case. Other than we also get the channel defines for the sliders. So we do know, I guess we can infer from that the buttons are going to be play, stop, record, and maybe like tempo or function. And from that, we can kind of infer that we're not going to be pushing these things like repeatedly really fast and have to debounce that, but rather it's going to be a very definitive press and then not pushed again for maybe 30 seconds or something. So it's not like a high frequency button where you're just going to be mashing it. In which case a hardware debounce might make more sense. I don't know. I'm not a MIDI guy either. The guy who requested it is not, I don't know if he's here right now. So I will be running this by him and asking him to review it at different stages, and we can always change things later. What we're going to do for the whole development process is everything we're going to use on the PCBA is going to be a through-hole part, not a surface mount. Makes it easier to solder, but also you can put them in breadboards. And so we're going to draw up our schematic and pick out our parts, But before we design the circuit board, we're going to order all those parts, put them in breadboards, and test it and start writing code. And that way we can see if we can at least make this thing work. It'll actually go into an assembly as part of the last bit of the design, because the assembly itself is not super important on how it looks, just that it functions. All right. Search teensy. I think I have my libraries enabled. I do. Okay. We're going to use a teensy 4. Okay. So this is great because not only does it already exist, but it has a package for it and everything for the circuit board. So we're going to just drop that right there. And then this is the part I was scared about. I don't actually know how to make a custom part in this yet, and I think I'm going to have to, because I think whatever parts we pick out are not going to be like are not going to be standard things or are already in this library. How many does it give me if I search potentiometer? Probably a lot. Series, logarithm, through hole. That's optimistic. Okay. Let's find the parts. All right, I'm going to pull this up. And we're going to go ahead and search them. Slide potentiometer is 828 items. Nice. Oh, that's interesting looking. It's really small, though. All right. And then another thing I've already done is I went ahead and made a BOM document. So item. Is this for schematics or PCB layout or both? It's actually both. You design your schematic, and then you create a PCB document, and then everything on your schematic gets moved over to your PCB. So all the parts that you place in your schematic have a corresponding like model or footprint for the PCB. It's pretty neat software, and actually, a lot of PCB design software these days works that way. That's how it's set up. There's two components. There's the schematic and layout in both one software to make it as easy as possible. So, all right. So we need an item. We need location. We need part. Or we need a quantity. Description. And maybe a link, because I imagine wherever we get this stuff from, we're going to want to be able to get back to it. Right, yeah, so the specific part matters. But it matters anyway because even a slide potentiometer has different numbers of pins that have to be connected, depending on which one you pick. All right, so I'm going to keep this off screen probably. There's no reason for you all to see me fill out the spreadsheet, but I will search for parts here so that you all can see and help me out. So we specified a couple things, and I don't know necessarily that we'll find it on this website. We might have to get creative and look around different websites, but we specified that it's going to be 60 millimeters. And then though it needs to be a through hole type part. And actually, we can pick this chassis and panel mount, because sometimes those will work as well. We just need to make sure that we don't do surface mount. Okay, there's 216 remaining. All right, next. Oh, some of these are in stock. That's cool. All right, next we decided that we would prefer if these were illuminated. We want them to light up because that seems cool. So let me select that. Now we're down to, how many are we down to? 39. Okay. And it looks like all of these are basically made by the same company with only 2 of them in stock. We'll look around to see what else can be found on Mouse or whatever. A lot of these are copies because you have to buy so many at once. There was one company that was different. This one. 1,000 non-stock. That's not really useful. All right, so the only ones that are in stock are up here at the top, which we have this one and this one. And the only difference, there's a little bit of a difference, but I'm suspecting the difference is the color of the LED, which I think white would probably be best, just for a nice clean look. And I don't remember. I think I've looked at these before, and I don't remember what the how to tell what the colors are. But we can go to the data sheet, and it will give us a breakdown of the part number and what everything means. Because typically these companies like to use their part numbers. The part numbers really are a description of the device itself. So we just have to find that. Circuit. Here it is. How to order. All right, so in the how to order section, they will give you a lot of different possible values and tell you what the breakdown of the part number. So this whole thing is the part number, but obviously they mean different parts of it, as shown here, mean different things. So the first part, PTL, is always going to be that way. That's a slide potentiometer with LED from this company. The second number, or the second item, is this number, which is our length of travel. So whatever we order needs to be a 60 because we want 60 millimeters, a PTL 60 dash lever length. Ooh, that's interesting. I did not even consider that. We're going to have to model that. I intend to model this in CAD at some point because this circuit maker software that I'm using to design the PCB will allow me, when I after I'm done laying out the PCB, I can actually export a 3D model of it and the parts, and then I can import that into some sort of CAD program and then model around it and check that everything fits. So that'll be cool. So this we'll leave kind of open-ended for the moment. We might have to buy a different one depending on what exactly it looks like in the CAD model. It looks like this right here is our important one, this letter. R is red, O is orange, G is green, A is amber, W is white. So we would like a W there. And then detent versus no detent versus center detent. I'm assuming we want no, so a 0. And then finally resistance code and resistance taper. Interesting. So those aren't going to be as important. We can model them in software no matter what they are, but it's good to know. Okay. So here we can see that it's G and it is a 1. It has a D10. I need to figure out exactly what that means, but it's G, so it's green. So we don't want a green one. So we go back. Oops. Didn't mean to do that. I want to keep our parameters. Okay. So we know that the ones they have in stock that are 60 millimeters are green and orange. Neither of those are really what we want. So, and nothing else is in stock, but I wonder if we can find the one we want. It needs to be a white. Midiing are the sliders 0 to 100. I don't think so. I think they're like 0 to 10, but they're floating point values. But we're going to have to do a conversion anyway because our ADC is going to be some sort of, it's probably a 10-bit, so it's probably going to be a 4096 levels that we'll have to convert to a floating point between 0 and 10. Red, green, green, amber. Green, amber, green, green, orange. Do they not list white in this size option? If not, we're just going to go with like orange or something. Are the sliders 0 to 100 or plus or minus 100? I don't know. I think I'm understanding your question correctly, but I'm not sure. But the answer is I don't actually know. I guess we could pick either of these. They're the same footprint. I just don't like the resistance changes. All right, I pulled up... let's see. I pulled up Mouser over here. I'm going to Google this real quick and see if I can find any other variants of this particular one. Because I do like this switch, but... Oh, I see what you're saying. Okay, yeah, so it's not plus or minus. It's definitely 0 to something. I'm pretty sure, but I can check that later, and we can always order another option. At least the benefit to this is that they should all have the same footprint. Well, 60. And I'll actually just pull this up here so you can see what I'm doing. Okay, 60, and how many does it give us? 302. That's not bad. Through hole. Let's just leave it up to through hole and see what we get. 49. Oh, we said illuminated, right? Is that an option here? Not really, and I think that was not a good one. Let's reset that filter. Bourne's is the company we were looking at earlier. Let's try that. Wow, 239. They've got basically all of them listed. They have a lot more stuff in stock too. Did I accidentally clear a wrong filter? Because it looks like some of them are... Nope, interesting, okay. We want the PTL parts. Looks like PTA is the same thing as the ones we were just looking at, but not the lit up version. PTL 60, orange, green, red. It doesn't look like white's an option in the 60 millimeter. But they have a lot of these in stock, so that's promising at least. All right, I know that we like these 60s a lot, so let's just do PTL 60. And search from there. See what we get. 71 results. I'm going off by items in stock because that makes it easier on the other end. You know what item... The stock generally represents what they tend to keep in stock, and things that are listed as 0 are things that you'd have to special order. So I am trying to find something that's already in stock because it's usually a good guarantee that I can get it later, that they won't run out. But finding a white one is apparently going to be really hard. I might have to go with a different color. And Mouser's search parameters are not good enough for me to be able to specify that, so... Here's white. Non-stocked. Okay. So we're in the non-stocked item now. So white is not generally stocked. Lead time is 22 weeks. That is a bit much, a bit more than I'm willing to wait. And it looks like there's a minimum quantity of 750 if you buy a non-stocked one. So That's odd that white is such a weird one. Okay, let's go with one of the ones that's in stock. I'm leaning towards a 10K resistance. Rather than 100. I'm a little worried with the 100 on... If you make the resistance too high, it gets a little weird on the input because the input to the TNC has a certain impedance. And if you exceed that, or not exceed it, but like if the impedance of the voltage divider that you're measuring is very similar to the one on the TNC, then your measurements can actually get very hard to do because you have to, instead of doing just a basic voltage divider calculation, you now have to do Kirchhoff's law of, current in equals current out at the node, and the voltage divide over the whole system and everything. And the calculations get a lot more complicated and difficult to model in software. So I'm leaning towards a lower resistance because the TNC input impedance is going to be a very high resistance. And if it's, an order of magnitude or even more higher, then it basically negates, you can basically ignore that part of the equation. You can just assume it's more or less a perfect system. So it looks like we're going to have to pick a color. So yeah, exactly. Yeah. 10K is a good choice. I think 1K is too little. Especially with a 4096-bit ADC, but 10K is like kind of that sweet spot. I'm sure you could do the math on that too. So let's see. We have orange, green, red. Let me search. Let's see here. Let's do the resistance 10K and see what we get. 12 remaining. See what our options are. And we'll pick from one of these colors. All right, we get red, green, orange, and amber's non-stocked. Okay, red, green, or orange. Which of those is best? This is for everybody watching right now. Tell me which one I should pick. Green? Green for the sliders? Okay. I think that works. Could order one of each since there's 3 sliders. But they'll all have the same footprint, so we can change those out later if we decide we need to. Okay. The only other thing we need to consider, you said, orange, huh? It looks like the length of the actual switch. Oh, actually, orange might be a good choice because we can actually get it in a longer form factor if we need, like a taller one if we need to. I actually kind of like that idea, going with orange. And we can get it without the detent as well. Oh, that's a perfect part right there. This is the one. All right, let me fill out my spreadsheet with that item real quick. Man, an hour has already flown by. All right. Oh, that was the wrong spreadsheet. Item number 1, location, R1, R2, and R3. I'm actually going to pull this up so that everybody can see this real quick. I know it's going to be really small. I apologize. Here, I'll zoom in a little bit. So item we generally mark as just indicator, item number 1, item number 2, so on the BOM. Location, R1, 2, and 3. Quantity, obviously that's 3 because we have 3 locations. Our description is actually supplied by Mouser themselves. It's right here. Slide potentiometer, 10K ohms, travel equals 60. That's whatever's in that description is usually great for the BOM as well. Or pretty straightforward. You can get more descriptive if you need to, but let me make sure I don't include any of the formatting and formatted text. Okay, thank you. And then we need a link. So I'll move that off the side. That's basically what each item on a BOM is going to look like. In actual like commercial stuff, it'll be a lot more specific. You'll include pricing info as well as other things. and maybe even packages, form factors, that sort of stuff. And then oftentimes you'll include alternates as well. If a component is difficult to source, you can include several different alternates for a specific item, and whatever they're building that day, they can pick one. Especially right now, the electronics market kind of sucks. These lead times on things are ridiculous. So, okay, so that's picked out. I want to see. I would prefer ordering everything from the same site, because that would make it easiest. It may or may not be possible. So I want to see if they have a TNC4 on this website. They have a 4.1. Here's a 4.0 USB development board. I need it with headers. So let's just search this and see if I can find any that come with headers. 759 in stock. It's from Adafruit. Doesn't look like it comes with anything. We might have to buy the headers separately. Headers are basically, actually we can go look it up, but first let me include this. We're going to call it U1. Chips are generally regarded as a U number on the PCB, and actually on the PCB itself, we'll put down a print on it that has all these labeled so that we can see exactly where everything goes. All right. So this TNC4 is the exact same thing I used in the Falcon, except it's the variant that doesn't use or doesn't have the SD card, because that isn't necessary for us here. And as a result, it's about $10 cheaper. That SD card slot was apparently, because the board was bigger and everything, add an extra $10 to the cost. So I paid like 33-ish or so for it. You can see here 25 is the unit price. Factory lead time, 21 weeks. That's actually way less than a lot of things. That's impressive that they got an entire board with less lead time. Okay. And then we need a link to this. We're ordering everything off Mouser. All right, next item. If we refer back to this, TNC slide potentiometers, buttons. We need push buttons. Push button switches. Now, if this ever loads, that was weird. There we go. You'll notice that this is a very type of common item, and so they have 65,000 options for us. Which means this is going to be really hard. And we may have to change this later for whatever's going to... Oh, man, this is actually going to be really tricky because it's got to fit in the case. So this might have to be creative. All right, we said we probably wanted them to light up. And actually, let's just go ahead and select in stock and active. Let's just go for new parts. All right, apply all those filters. Illuminated knife switches. What's a knife switch? Oh, it was a joke. Okay. I missed it then, sorry. All right. So we apply these filters. All right, we're down to 2,758. And then we need stuff that's through-hole mounted. Let's see what this gives us. lamp. These are kind of interesting with the rings. I'm not sure how I feel about them, though. $19 high. That's pretty tall. I'm worried this thing's going to kind of stick out of the top of the shell. Because the shell is only like, depending on what we pick. I guess we got to know that. And I would like to get a different color one. Holy crap. Never mind. We're not picking this. Look at the unit price. $50 for one switch. Nope. Sorry. Let's sort by price. I refuse to pay $50 for a Switch. I think that would be very irresponsible. No, these are very short ones. It's going to have to stick up somewhat in order to be usable. This might work. What is this? Illuminated push button. Looks like you can get them in different colors. What are all the color options? Black, white, green, red, or yellow? We need white, green, and red. I don't know about... I guess that works. Yeah, we can get a yellow as well. All right. This actually may not work out necessarily. I think these are going to require... These are made for like factory use, and they might require a 12 or 24 volt DC system in order for the light to work. We need a low voltage LED thing. We may not be able to do illuminated here, which is fine. It's annoying to have to give up on that, but it was just a requested as a want, not a need on the requirements. And cost-wise, illuminated ones are very expensive as well, so... Yeah, we can't use that necessarily. That actually may be true of most illuminated switches because they're really designed for like factory type use. So finding one that we can use that's illuminated may not be possible. What is this? They have different heights available. That's kind of cool. 50 milliamp, 24 volt DC. Yeah. Yeah, we may have... Oh, that's unfortunate. How's it going, Beth? Okay. Let me look at real quick. I should probably go to like a hobbyist website rather than a supply website. Let's go look at Adafruit, see what they have. Maybe entirely possible that they have something. Illuminated push button. Okay. This is promising. I want a momentary, whatever it is. I would like to get different colors. We might be able to find out what the exact number of part this is and then find it on a website, on Mouser or something. I didn't think about this, though. We could not have to worry about the height if we just, what is it? If we just solder wires to it, which may be what we actually need to do. Medium-sized button, large enough to press easily, but not too big that it gets in the way of your project panel. Has a built-in LED that can be controlled separately from the switch action. Either to indicate or look good. That's exactly what we want. I just want them to light up. Body is black process LED built. There are 2 contacts for the button, 2 contacts for the LED, one marked plus, one marked minus. LED is about 2.2 volts, so connected. Oh, I forgot about the resistor. Yeah, we're definitely going to need a resistor for the LED. We should probably add that to our PCBA. Didn't even think about that. But, all right, so that looks good. So your button has a red body. LED is momentarily normally open. Makes sense. The 2 switch contacts are not connected normally. When you push the button, they will temporarily connect until the button is released. The LED is separated from the button so you can make it light up when not pressed and light up when pressed, not always lit, etc. That makes sense. I'm sure the pinout's not too hard to figure out. The thing I'm most concerned about is the height, but that shouldn't be too hard to work out too, and the width as well. Buttons, especially these lit up ones, can be surprising how big they are. So, what's the width? I can't really see this. 18 millimeters, it looks like, across. So if we got 4 of those, that's going to be like 4 inches when you include space between them. I wonder if we can only buy these here or if we can buy them as elsewhere. If they have if they're from another company, if they have an actual part number. I'm not seeing one. But I think this could work. I'm willing to go with it. So let's go through the colors real quick. We need a record, that's red. We need a stop, that's white. We need a play, that's green. And then we need a tempo/function, so a 4th color, I guess, of our choice. We could use orange, or we could use blue, or whatever else they have in stock. It looks like basically all of these are more or less in stock. So it says 16 millimeter button, but it's just 18 in the actual schematic. Interesting. I think this is fine. These could probably work. I'd be curious what they feel like. But I don't think that's going to be that important. So separately. I like these. I like these a lot. So let's go ahead and pick these out. I'll pull up my bomb and we can see. For those of you that don't know this, BOM stands for Bill of Materials. All right, we know we need 4. Now, because we're going to have to use different parts, so we're going to have 4 switches, but they all have to be different colors, which means a different part is going in each switch location. We can't put all these in the same row of our BOM and pick and say use 4 of the same switch. We actually specify 4 different items. 3, 4. All right, so momentary or latching? We would definitely want momentary. We don't want it latching. We just want to detect the press and then send the appropriate signal to the computer. Illuminated, and then, so we need a red. Oh shoot, do we specify an order? We might have specified an order to these buttons, like left to right, which way they should be. And if that's the case, we should follow that. Here we go. Play, record, stop, tempo. I feel like it's not correct. What would be the right way to do that? Is it play, stop, record, tempo? Like if you're looking at this on I don't know, a DVD player or something, or I guess if it has a record, maybe it's an old thing, it's a VCR, right? What order would those buttons be in? Tempo's going to be last, but what order is the play, record, stop? Because whatever that is, that's the order we should go with, and that's how we should specify this as far as switch 1, switch 2, switch 3, switch 4. Any ideas? Does nobody know? I mean, that's fine. If not, we'll wing it for now. Maybe I can ask the guy who requested this project what order he wants those buttons in. You're good, Terrence. We're trying to figure out. I have our requirements here. I have the play, record, stop, and tempo button, and the tempo button should be last. But the play, record, and stop, what order does that go in? What order would those buttons be in from left to right? You know, if you saw it on, if it has a record, it's probably like on like a VCR or a DVD player, or some sort of media player. What order would those buttons be in? I cannot remember for the life of me what they typically are, or even if there is a normal order. Because that matters what order I'm going to put them on the BOM as switch 1, switch 2, switch 3, and switch 4. Maybe plays first. Play, stop, record, and then tempo. Yeah, maybe I'll go with that for now, unless anyone has a better idea. And then I will ask the guy, I will ask our play, stop, record, tempo. I'm actually going to change that here so I get this order right. I'll ask our customer. What exactly he wants. Okay. So let's go. So play, record, stop, tempo. Play, stop, record, tempo. Play, stop, record, tempo. I have a VCR downstairs. Really? I'll look. All right, that's solid. If you're willing to go look for me and put that effort in, I really appreciate that. I really, really do. Just so everyone else knows, any advice, feedback, suggestions for the design, like this channel, I'm doing this stuff because I enjoy it, but I want to show that, or I want to make something better than I could have made myself. So if you have an idea for something, for how to do something, or a correction, or something that you notice that I've done wrong, please let me know. I appreciate the feedback. I really do. All right. So he said play. So that would be the green. Green is a play. I wonder why. So notice this. The blue is $1.95. The white is $1.95. But green is $1.50. I wonder why those are more expensive. I mean, I guess certain LEDs are more expensive for certain colors, but that's just interesting. And then also what we should use for our tempo. If we should use blue or yellow. It looks like those are the only other two options. Let's use blue. I like blue. Okay. And now I got to go in through and get all the links. So you have a red momentary. Adafruit's product numbering system is the easiest to copy and paste. All right, got the red. We're doing a white. All right, we need a blue momentary and then a green momentary. Green is the only one I don't have. Okay. Okay, and then one last thing. So that's put into the spreadsheet already. So anybody that's interested, this is what our bill of materials looks like right now, with our 3 slide potentiometers, our TNC development board, and then our 4 switches, all on different items because they're all different colors. Last thing we need are resistors for each of the LEDs. So R4, R5, R6, and R7. We need 220 ohm resistors for each one since we're doing a low voltage system here. Play, stop, record. Okay, so we got the order right. Green, white, red. Excellent. It was a really good guess. Thank you for verifying that. I really appreciate it. All right, so the last thing we got to find is, since I forgot, these LEDs are going to need a resistor of some sort. So let's find some resistors. Luckily, pretty common item. Oh, we only have 667,000 options to pick from. All right, this should be pretty straightforward. In stock, active, so not a last time buy product. And then we want, let's apply those filters and start with that. There should be more filters than this. Resistance, we want 220 ohms. It's weird that they put the mega ohms before the ohms. I went past it. I wasn't even thinking. Had to look at 3 different remotes. That's really funny. Well, I appreciate the effort. 220s. It still leaves us down with 675. And then we wanted a through-hole part. And these could be 100 milliwatt resistors. They don't have to be a whole lot. Wow, really? Oh, they must not label them as like through-hole. It's like that can't be. It's probably axial. Oh, what's wire lead give us for? Yeah, axial I think is the actual termination for the actual name for that. 0.25 watt. That's probably that might not. I think 1/8 would be okay. All right, this is acceptable. These are what we want. But we can always. Well, actually, it may not be that hard to get a 1/4 watt. All right, fine. We'll look at them. 250 milliwatt. It's gonna be a big resistor. $1 each. Those are expensive. There we go. 10 cents each. Carbon film, metal film. like how this, what appears to be a really popular one, is doesn't even have a picture for it. Well, that looks pretty straightforward. And shouldn't be that hard. I just need 2 vias on the board, and that is essentially your resistor. I'm sure we can find a part that will match close enough. Okay. Let's just go with this. It's cheap. They have 67,000 in stock, and they're 10 cents each. Sounds perfect to me. And let's get a link for that. There we go. Okay. I think, for now, we have a completed bomb. This is just in the PCBA right now. This is not of like the whole assembly. We will have to add items or possibly make a second bomb that includes the PCBA as a single item on it. And then from there, we can add all the other items like the shell and all that stuff. I'm not as worried about picking out the enclosure right now because all these parts are modular enough that they'll work with just about any enclosure. So I think next thing's next. We need to actually design our circuit. And now that we know what we're doing here, kind of, we might be able to, oh man, these, I don't know if these PTL parts exist here in this octopart library. I might have to make them. It's PTL 45. 1 mega ohm. Oh, wow. They do have one of the parts that we were talking about. Whoops. The PTL parts already in here, but it's a it's the I lost it. There it is. It's the 45 millimeter version, not the 60. So the package won't be the size won't be correct. So we're gonna have to make our own part there, which is kind of disappointing. Also, I didn't think about the Adafruit like push buttons, if those would have a footprint. Here. Just select all of these. Just search through everything when we're doing this. Make sure all of our libraries are being used. Okay. I don't think this is going to change anything. I just wanted to make sure that we were selecting everything. Okay. Then I think what we need to do is learn how to make it. Let me go back. Actually, let me get this link. Oops. Just pasted that in the middle. Is there any chance they have CAD? Build or request PCB footprint or symbol. Download the free library loader for the ECAD. We can request it. If we go onto the website, maybe that'll have the CAD on there as well. All right, I might have to do that outside of stream because that'll be a lot to look into and kind of boring. I got to do some of this though, so let's get at least some of the schematic together. Resistor. There's probably a lot of stuff here. Axial. Let's see. This looks good. This, whatever this first one is. Okay. Whoops, didn't mean to do that. I don't know how to rotate things automatically in this, but all right, we're gonna need this from 3.3 volts out. Where should we put these? Probably over here. We're gonna need 4 of them. Wow, this is very similar to the one we actually picked. All right, cancel that. And then I need to move this over here. And move these. I know this isn't the resistance that we were going to use, but it is, it's the same footprint, so in this case it works just fine. It's not the same resistance value, but that's okay. All right, let's place some wires here. I don't think there's any need to control whether or not they're illuminated from the micro, although that would be kind of cool. But I'm not confident in the output ability of the pins, so I don't want to do that necessarily. Okay, and then we need to name these. Properties. Designator. Okay. Oops. That's the error it's throwing right now. It's highlighting them all with a red underline because they're not named something unique. There we go. Our 4, our 5, our 6, and our 7. And then we probably need to name this wire. Oops. No. Don't care about that. Do care about... Nope. Is that a sheet? Nope, I don't want that. What is the thing I'm looking for to name it? Net label. There it is. There we go. And we're going to call this net 3v3. And then over here, we'll do a wire as well. I guess out from this one. And add a net label to that. And 3v3 as well. And by naming them the same thing, the program will realize that they are this thing will realize that they are connected, even though they're not actually drawn to be connected. So that'll be cool. Okay, so now we have those resistors. Now we need to come up with something for the button. So, unfortunately, I don't know if there's Adafruit parts in this. Let's see if we can find something. Choose. I mean, I'm sure there is. I just don't know if there's, like, Adafruit, like, buttons. Push button. No, that's not it. 2 variants, but neither of them are this thing we need. And I don't think those are, like, Adafruit specific parts. Like, I think that, These push buttons might be something else, that some other manufacturers that they're just selling, but it doesn't tell me here that. Yeah. Maybe Mouser will tell me. Let's see, what is this? 1440? Maybe Mouser just has them. Oh, they do. Wow, okay. Are they in stock? They are. Interesting. Doesn't show a data sheet, though. All right, we probably got to make our own, like, quote-unquote package for this, our own part as well, because it's got the LED and the push-button part. So I think that's something... Okay. I probably need to learn how to do that outside of the stream, because although... Unless anybody could tell me right now how to make a new part in Circuit Maker. I'm sure it's not that super complicated, but I don't know how to do it, so... Here. How to make a part in circuit, or how to make a component in Circuit Maker. Wait, interesting. So if you make a custom component, I don't know. I think it sticks to this project, but I don't know that you can share it. Projects. Let's see. Build your own. At the bottom of the library panel window, there is a build your own. Libraries. Date. Here it is. Build your own. I clicked on it. Let's see what this does. Can you copy and extend an existing part? You might be able to. That would be really cool if you could. What is this name? Add new symbol, add new footprint, add a new simulation model. Oh, you can simulate things in this. That's kind of cool. I didn't realize you could do that. We probably won't bother with sim models. But we will need to make a symbol and a footprint. So what is this? Push button, add a fruit. 1440, I think is the one I was looking at, which is the green one. Yep. Okay. As far as the layout goes, it's not very specific because what we're going to do is solder wires to the button and then come over and solder wires to the board rather than having them directly mount onto the board. And that way we can control the height a lot easier, and it works with our enclosure. So description, I can pull this one. So I'm just going to kind of try this real quick. Whatever I do here may not be, I might just throw it out and start again once I realize all my mistakes, but I think this is a great way to figure out what mistakes I'm going to make. So let's just give it a shot. Manufacturer, add a fruit. Sure, part number 1440, because Adafruit has just generic part numbers. Okay. Click to add a new symbol. And then I assume I gotta draw it. Oh, it's got pins too and everything. Interesting. Well, we need 4 pins. Oops. Is there a... How do I rotate? That doesn't rotate. Nope. Page up, down, maybe? Nope. I don't know the keyboard shortcut to rotate in this program. I think I have to rotate. I think these ones are fine. Actually, I got to rotate these ones. Place. Nope. Archive view. Properties. Orientation 180. I just don't know how to change that offhand, but all right, there we go. 0, 1, 2, 3. We could probably drag these over to make this a little more symmetrical. And then typically on these as well, you can turn off like values and things like labels. I want to turn off this value right here. Not that one, that one. Display naming. Okay, there we go. Properties, turn that off. This might actually work out. So far it's going smoothly. And then, there we go. Okay, and then we have a switch. So, we need a line. I also don't know what the scale is. This might end up being like really tiny and I just don't realize it. Whoops. And then one here. I think is how that usually works. And then, whoa. Hold on, zoom out. There it is. I do not recommend their navigation tools necessarily. All right. I need a circle. Maybe a bit smaller than that. Yeah. Line was small, start angle, don't care. Radius, 5, I guess. Okay, yeah, 5 looks good. And then color, black. And can I not fill it? Why is that not an option? Could say large, that looks kind of weird, but should be a way to do like a filled shape. But I guess not. All right, well, we'll go with that for now. Make a second one and drop it there. Cool. I really just like hate the way that looks. We'll go back to the small. That just looks better. And oh, we don't need that one. We need this line. There we go. There. Now let's do that. Do like to make sure all the symbols look semi-correct. Okay, so that's the switch, and now down here we got to draw essentially an LED. It's not too bad. There we go. And then they usually have little arrows coming off them. I'm not totally sure how much we should do here, but I could try that real quick. See if I can make it. Nah, I'll just ignore it. It's fine. As is. Alright, so there's kind of a schematic symbol. Okay. So now that's there. And kind of looks correct. Then we need to add a footprint, which I'm not ready to do just yet. That'll take a little bit more learning. But we can do that later. Oh, I don't need it. So there's more parameters. Interesting. Okay. I'm not totally sure how to do all that yet either, like name it different things and such. But let's just save that. And then go to our schematic here. And then place a component. And I'm assuming we can access it. But I don't know where. Oh, project. Nope. Favorites. Nope. It hasn't shown up yet. All right, so I've made a part basically, but I'm not totally sure how to use it yet. See if I can find some instructions. Excuse me. If community vault component is not available for the component you selected, the icon is not shown. It can be created within Circuit or auto added to the vault for others to share. Circuit provides component editors for defining components, parametric information, and models for all design domains. Component. Interesting. I may not have done that a very good way. Adding a footprint. Commit to the vault. When the component is saved, automatically retained. To save the new components models on the vault, click the Home and Commit button on the ribbon menu. Oh, here it is, up here, commit. Okay, so once it's committed, hold on, doing something here. It's got to commit everything. Hopefully I can go back and edit that later. Now if I choose a component, here it is under my favorites. I don't know if it's supposed to be there, but it is there. Wow. Drew it bigger than I thought I did. But this gives us a start, at least. We can drop them in as necessary. So we need 4. 3, 4. Okay. And then we might have to move some of this stuff around. Actually, let's just slide this whole thing over. And then we will slide stuff down as necessary. Close enough. All right. Then we take our wires. We got to connect these to the LEDs. Oh, this one's slightly off. I was a little confused about that. All right, there we go. Okay. And then we're going to need wires for the input to the switches. I think I'm almost done for tonight. We'll have to go through still and edit some components, but that's fine. All right. Put net labels on each of these. And then on the other side, we need to connect our wires into the appropriate thing. And so the switches, let's see here, the best way to do this. Probably slide this whole thing over just a little bit farther so we give us a little more room. And then a single wire connecting all of these LEDs to ground. Let's drop a ground right here. All right, and then for these, we want to have inputs to the teensy. Okay, and then finally, we need to name them. Switch 1, switch 2, switch 3, and switch 4. Okay. And then these need to be the 3-volt line. Okay, so that gets our push buttons and our teensy in there. Everything's kind of spread out right now, and probably a bit overkill in terms of that. We might be able to slide this to make this more compact, because we still need to add in our slide switches, our potentiometers. I think for tonight, though, I think that's going to be all of that I do. I'm getting kind of tired, and done a lot already to kind of design it. So next time we'll have to keep designing the schematic. I'm going to try and tomorrow night just do a little research into how to make a new component, and that way we can make a custom one. And yeah, hopefully there we can make really good progress, and I'll double check a few things just to make sure all our parts look good, just to make sure there's not any major unforeseen things coming up. And we'll go from there. Once this circuit's designed, we'll order our components, and then we'll start writing software for it. So, should be pretty cool. All right, thank you all for joining me tonight. I know this was in-depth and a lot of details, but I really appreciate all the support and those of you that helped. It really means a lot to me when you all do that. So, thank you for taking the time to stop by and give me advice, and I will see you all later. Have a good night.